Assalamualaikum. Hi, good day. So this is the third part of topic 4, the biocatalyst section. Okay, so in this topic, we are going to look at the rate of biocatalytic reaction, where you can also refer to the textbook, Schuler and Kargi, in chapter 3. Okay, so previous presentation, I've mentioned you on the Maclaurin-Menten equation, okay, and also the plots of Maclaurin-Menten, which you can see here. So from the plots, you may be able to find the Vmax and the Km value, okay. But I also mentioned that the Vmax K value in the Maclaurin-Menten plot is very difficult to be extrapolated due to the hyperbolic shape, okay, of the graph. So we just take the highest point as the Vmax. Okay, therefore, because of this reason, there are 3 types of linear plot that are available, in which these plots actually its origin from the Maclaurin-Menten equation, in which this Maclaurin-Menten equation is being linearized in order to have these 3 plots. Okay, so let us take a look on the first plot. It is known as a line-Weaverberg plot, or also being called as a double reciprocal plot. Okay, if you can see here, the equation here, okay, it came from the equation of Maclaurin-Menten. It is being the Maclaurin-Menten equation is being linearized, so that we able to get this equation of line-Weaverberg. So this equation represents the linear equation, which is y equals to mx plus c. Okay, so this is m, the slope, and this is the interception at y-axis, interception at y-axis. Okay, and you can see here from the plots, okay, you may able to find the value of Vmax at the interception at y-axis, okay, and if you plot the graph by using graph paper, then the interception at x-axis is the value of -1/km. Therefore, you can calculate, you can find the km value from the interception at the x-axis. But if you're using the Excel, then you can use the slope value from the linear line equation. Okay, if you plot a trend line, then it will give you the equation of a linear line. Then from the slope value, okay, slope value, which is m, okay, you equalize with km over Vmax, okay, in which you already have the Vmax value, okay, from the interception at y-axis. Substitute, and then you can determine the km value. Okay, this line-Weaverberg plot or double reciprocal plot is very good to be used for analysis of 2 and more substrates in the enzyme reaction, and also it can be used in order to identify the type of inhibitions in the enzyme reaction, okay, in which the inhibition we will take a look on that later, okay, in the next part. Okay, so this is the first plot, linear plot, and this linear plot, the line-Weaverberg plot, is mostly being used everywhere for the enzyme kinetic study. Okay, the next plot is Edie-Hofste plot. Okay, so Edie-Hofste plot, okay, similar. The origin is from the Maclaurin-Menten, okay, which the equation is being rearranged to become a linear equation. Then from the plot, you may able to find the Vm value at the interception of y-axis, and the Km value, okay, you can find from the slope of the graph. Okay, this graph is a negative graph. Okay, negative slope, negative linear graph. So therefore the slope will be negative value, but the km value, if you write the km value, it will be in positive. Okay. Okay. However, this kind of plots, it always give a large error because of the tabulated data is quite far from the linear line. Okay. So if you can look at this note. Okay, since both coordinates contain V, but there is less bias on points at lower S, means that at lower concentration of substrate, okay, the data will give you a very large error, okay, compared to the line Weaverberg plot. Okay, the third plot is called as Henness-Wolf plot. Okay, and this Henness-Wolf plot is also known as a Langmuir plot. Okay, so equation 3.15 is a linear equation of Matrix-Menton also. So similar, this is Y, okay, this is M, sorry, this is C, okay, this is M, and this is X. Okay, so from the plot, okay, the interception at the y-axis, okay, is km over vm, and the slope of the plot is 1 over vm, and the interception at the x-axis is negative, okay, km, right? Because if you can remember what I mentioned in the Matrix-Menton plot, km is the value of substrate. Okay, so here the x-axis is substrate, right? Okay, therefore this interception at x-axis is km value, but it is negative because the value is at the negative side of x. Okay, alright, so if you plot this graph by using graph paper, then you'll be able to find this km value, okay, on the graph. But if you're using Excel, so it's quite difficult. We're just referring to the linear line equation here, and then you find the value of slope first, 1 over vm. Okay, then if you already have the vm value, then you use the vm value, alright, to identify the km value, okay, based on the value of interception in the equation, interception of y-axis, okay, in the equation. This plot is used to determine Vm more accurately compared to line Weaverberg and Edie Hofste. So if you have a data and then you plot the Henness-Wolf plot, you may be able to find that this kind of plot, it will give you a very accurate reading in which the tabulated data is very close to the linear line drawn. Okay, the linear line drawn, if you're using the Excel, it will be your trend line, the linear line trend line. Okay.